My name is Fekede. I am associated with Texas AgriLife Research Station in Bushland, Texas. I am Charlie Rush's program, and my role in this program is to study the epidemiology of zebra chip and study what affects the incidence of zebra chip, and in the long run, after identifying the variables that affects the disease, come up with some predictive models. We've been working on this for the last 3 years, and from South Texas to Nebraska, and then the last 3 years we worked on a total of 27 fields in which we monitored and counted the number of infected plants in 27 fields. And the data I present at this time now is a result of this. We are still working on identifying what variables are important to zebra chip, and maybe also, even though I'm not an entomologist, maybe also look at what affects the psyllids. And now, the reason we are doing that is that there are a lot of variables that we really don't know until now. And we think that now, at this time, we have some handle on it. And the result I'm presenting now is we have variable disease. Some fields are near zero, some fields are quite high. And our interest in this field now is that why is this variable, we are seeing some variability in the field? Why do some have very little disease and some have high disease? So we have weather stations, we recorded weather stations, we have locations, we have a number of psyllids in these locations, the psyllid populations. So we put all this together and try to make some sense out of that. And the other thing is that these fields are sprayed. We don't have fields that are not sprayed. That is in a way not a good thing, because that will be another variable that will affect us for evaluating the disease's natural occurrence. So we also looked at what chemicals were applied, what were the frequencies, and what types were applied, and what does this mean? So to go back to our first objective of identifying variables, we found that location is one of the primary variables that affects how much the disease you get. Plus planting date is also associated with how much disease you get. And maximum temperature is also, we saw it to be very important. But these variables are correlated. So in a way, it is not good because one may mask the other, but in another way, if they are highly correlated, one doesn't have to use both, all the three of these variables, and one can only use. So the analysis we made, these three variables accounted for over 90% of the variation in the disease. So that is a good thing. This is really highly good thing to find out. And the fact that location is important is kind of interesting, because the model we plan to develop may not apply across the field. It suggests that we may need to develop models that forecast the disease based on location basis. So it tells us that we kind of suspected this from the very beginning, and it tells us that one model may not fit from South Texas to all Nebraska. That is what it is telling us. And it is obvious that in the South U.S., planting is early, the temperature is very favorable, so you get more disease. When you move up, it is getting warmer and warmer, so the psyllids may not like it, over 90, so you get a little disease. So one model may not be really efficient efficient enough for the whole area. So that is what we are coming up with for now, and hope to continue with this and come up with something useful to the growers in the next 2 years.